Questions number 1. Diagram 1 shows the straight line graph obtained by plotting xy again x plus y. Express y in terms of x. In linear law, what is labeled on the y-axis will be the capital Y, and the variables labels on the x-axis will be the capital X. To find the equation, first we are going to find the gradient. So here m is equal to 8 minus 2 over 3 minus 6, which is equal to negative 2. Next, we're going to find the c. So now the equation will be y equal to negative 2x plus c. To find the c, we just need to substitute one of the coordinates on the straight lines into the equations. So either you choose this point or this point. So let's say we pick 3 and 8. So the capital Y here we're going to substitute with 8 and the x with 3. So 8 is equal to negative 6 plus c. So c is equal to 8 plus 6, which is equal to 14. So now we can start forming the equation. So the capital Y here we're going to substitute it with xy. The m with negative 2. The capital X with x plus y. And the c with 14. So next we want to expand this. So this will be negative 2x minus 2y plus 14. As we want to express y in terms of x, then we're going to let the y to become the subject. So I'm going to collect the x on one side. So xy plus 2y is equal to negative 2x plus 14. Next, we're going to factorize so that we have 1y. So y bracket x plus 2 equal to negative 2x plus 14. So y is equal to negative 2x plus 14 over x plus 2. Questions number 2. Given that the quadratic equation p plus 1x squared plus 2qx plus 3 equal to 0, such that p and q are constants, has two real and equal roots. Express p in terms of q. So here the keyword will be two real and equal roots, which means for this quadratic equation, its discriminant b squared minus 4ac is equal to 0. As this equation has been written in general forms, by comparison, we know that the a is equal to p plus 1, b is equal to 2q, and c is equal to 3. So here we're going to get bracket 2q squared minus 4 times p plus 1 times 3 equal to 0. So 4q squared minus, so we can multiply the 4 and 3 first. So 12 bracket p plus 1 equal to 0. So 4q squared, so here when you expand it, you're going to get minus 12p minus 12 equal to 0. As we want to express p in terms of q, we're going to let the p to become the subject. So here I'm going to move this negative 12p to the other side. It will be positive 12p equal to 4q squared minus 12. So next I'm going to move the 12 to the other side. It will become divided by 12. So here we can simplify each term by dividing it with number 4. So p is equal to q squared minus 3 over 3. Question 3a. Given that the quadratic equations mx squared plus m minus 2x plus 3m plus 2 equal to 0, where m is a non-zero integer, finds the value of m such that one of the roots is the reciprocal of the other root. So here, let's say we use alpha to represent one of the roots. Then the other root, which is the reciprocal of this alpha, will be 1 over alpha. So here we know that the sum of roots is equal to negative b over a, and the product of roots is equal to c over a. As this quadratic equation has been written in general forms, therefore the a is equal to m, the b is equal to m minus 2, and c is equal to 3m plus 2. If we substitute it into the sum of roots, then it will be alpha plus 1 over alpha is equal to negative m minus 2 over m. As these equations have two unknowns, which is the alpha and m, therefore we are not going to able to solve it. But if we substitute it into the product of roots, then we're going to get alpha times 1 over alpha is equal to 3m plus 2 over m. So when alpha times 1 alpha, so here we can simplify it. Then on the left hand side, it will be just left with number 1. So when you move the m to the other side, you're going to get m is equal to 3m plus 2. So next, I'm going to move the m to the other side. So 3m minus m is equal to negative 2. Therefore, 2m equal to negative 2. M is equal to negative 2 divided by 2, which is negative 1. Questions B. The graph quadratic functions fx equal to negative x squared plus 2px minus 5p, where p is a constant, has the maximum value of 6. 1. By using the method of completing the square, find the possible value of p. So here we always need to make sure the coefficients for the x squared, which is the a, always equal to positive 1. As the a for this question is a negative 1, so the first step will be factorize. So negative bracket x squared minus 2px plus 5p. Next, it will be negative bracket x squared minus 2px. So here we're going to add in with the b divided by 2, which is the negative 2p divided by 2, and then square. Then minus the same thing, negative 2p over 2 square, followed by plus 5p. So now for this part, we are able to factorize it. It will be negative bracket, so here it will be x. For this 2 and 2, we are able to simplify it. So the things inside the bracket will be just negative p. So x minus p square. And for this part, after we simplify the 2, so the negative p, when we square it, it will become a positive p. But don't forget, in front of it, if we have a negative, therefore it will be negative p square plus 5p. So next, we're going to get everything out of the bracket. So we're going to get negative x minus p square. So when you expand this, negative will become plus p square. Negative plus minus 5p. So here we already changed the quadratic functions into vertex form. As the a of the quadratic function is a negative, then we're going to get a set graph. And based on the vertex form that we get, the coordinate of the maximum points will be p, and the coordinate y will be p squared minus 5p. The question stated that the maximum value of this quadratic function is equal to 6. The maximum value here is referred to the y coordinates of the maximum point. Therefore, p squared minus 5p is equal to 6. So this is a quadratic equation as the highest power is 2. So we're going to write this in general form. When we factorize it, we're going to get p minus 6, p plus 1 is equal to 0. So p is equal to 6 or p is equal to negative 1. Number 2, the graph of y equal to gx is the reflections of y equal to fx about the x-axis. By using the positive value of p from 3b1, write the functions of gx. So here the positive value will be p equal to 6. So if you substitute the p here with the value of 6, then the coordinates of the maximum points here will be 6, 6. So let's say this is the x-axis. Then the graph of y equal to gx, which is the reflections of the y equal to fx about the x-axis, will look like this. So here the coordinates of the minimum points of the graph y equal to gx will be, the x will be the same as 6, but the coordinates y will become negative 6. So here we can write the function of gx in vertex form. After reflections, the a will change from negative 1 to become positive 1. So here we're going to get bracket x minus 6 square minus 6. Questions 4a. Diagram 2a shows three straight lines. The straight line BC is perpendicular to the straight line AB and parallel to the straight line AD. Given the coordinates of the point B and C are 0, 6 and 3, 0 respectively, finds the coordinates of A and of D. First, we're going to find the gradient of BC. It will be 6 minus 0 over 0 minus 3, which is equal to negative 2. As BC is perpendicular to AB, so when we take the gradient of BC, which is negative 2, we multiply it with the gradients of AB, then the answer will equal to negative 1. Therefore, the gradient of AB is equal to positive 1 over 2. The point B is the y-intercept for the straight lines AB, which is the C. Therefore, the equation of the straight line AB will be y equal to 1 over 2x plus 6. Points A lies on the x-axis. Therefore, we can confirm that the coordinate y of the point A is equal to 0. To find the x-coordinate of the point A, we just need to substitute the y equal to 0 into the equations AB. Then 1 over x plus 6 is equal to 0. 1 over 2x is equal to negative 6. X is equal to negative 6 times 2, which is negative 12. Therefore, the coordinate A will be negative 12, 0. Straight line AD is parallel to straight line BC. Then the gradient of these two straight lines will be the same, which is equal to negative 2. Here, the point D is the y-intercept for the straight lines AD, which is the C. So now the equation of the straight lines AD will be y equal to negative 2x plus C. To find the C, we just need to substitute the coordinate A, which is the points lying on the straight lines AD, into the equations. So 0 is equal to negative 2 times negative 12 plus C. So 0 is equal to 24 plus C. Then C is equal to negative 24. Therefore, the coordinates of the point D will be 0, negative 24. Questions B. Diagram 2b show parts of the locus P. Finds the equations of the locus P. So here the locus P is a quadrant of circle. So here the locus P is a circle with the center at the origin. And the radius of this circle is equal to 10 units. The moving point P, which lies on this circle, its distance toward the center is always equal to 10. So we can say that PO is equal to 10. To find the distance PO, we're going to use the distance formula. So square root x minus 0 square plus y minus 0 square is equal to 10. Next, we're going to square both sides to remove the square root. So on the left hand side, we're going to get x squared plus y squared. This is equal to 100. Then the equations of the locus P will be x squared plus y squared minus 100 equal to 0. Questions 5a. The following order pairs represents the function hx. 1 finds the value of k. In order pairs, the number stated first here is going to be the object. And the number stated later on here will become the image. So if we convert this order pair into arrow diagram, then it will be look like this. Based on the patterns, we can say that the k plus 1 here is equal to 2. Therefore, k is equal to 1. Number 2, using the function notations, write the function hx in terms of x. So for functions that change the negative inputs into the positive ones, then we try to relate it with square or modulus. In this case, it will be modulus. So hx is equal to modulus x plus 1. To confirm the answer, you can substitute the value into the function hx. For example, h with the input of negative 4, it will be modulus negative 4 plus 1. The answer is modulus negative 3, which will give you the answer of positive 3. Questions B. Given that fx equal to x minus 3 squared plus 1, x is greater than or equal to m such that inverse f exists. Number 1. Determine the value of m. Here, the f is a quadratic function which returns in vertex form. Here, the value of a is equal to 1, which is greater than 0. So we're going to get a smart graph with the coordinates of the minimum points 3, 1. If we use the horizontal line test, it will cut the graph at 2 points, which means this function f has no inverse. But if we restrict the domain, which is the value of x when plotting this graph, then the inverse will exist. So this will be the axis of symmetry with the equations x equal to 3. So if we plot this graph with domains starting from 3 and onwards, then we're going to get half of the quadratic graph, which look like this. So if we perform the horizontal line test on the quadratic graph right now, it will only cut the graph at 1 point. Then the inverse of f will exist. So here the domain will be x is greater than or equal to 3. So if we do comparisons, then the value of m is equal to 3. Number 2, finds the range of value of fx. The range is referred to the sets of value of y or the fx. So the lowest points of this graph is equal to 1. As the domain of this graph is x greater than or equal to 3, then the value of fx will start from 1 and go on forever. Therefore, the range of fx will be greater than or equal to 1. Questions number 6. Given vector PQ 5, 7, vector OQ 2, 3, and vector RS K5. Finds A. The coordinates of P. The vector PQ and OQ is connected by the point Q. Using triangle law, we can write that vector PQ is equal to PO plus OQ. The O will be the origins of the Cartesian plane. So PQ is 5, 7. PO we didn't know, and OQ is 2, 3. Therefore, vector PO is equal to 5, 7 minus 2, 3. So vector PO is equal to 3, 4. To find the coordinate P, we're going to use the vector OP, as this means the points move from the origins toward the point P. So vector OP will be negative 3, negative 4. Therefore, the coordinate P will be negative 3, negative 4. Questions B. Finds the unit vector in the directions of vector OP. So in question A, we already find what is the vector OP, which is negative 3i minus 4j. Next, we're going to find the magnitude of the vector OP. It will be square root negative 3 square plus negative 4 square. which is equal to 5. Then the unit vector will be negative 3i minus 4j over 5. C. Finds the value of k if vector rs is parallel to pq. So if two vectors are parallel, then one vector is product of scalar with another vector. So here we can write vector rs is equal to lambda vector pq. So k5 is equal to lambda 5, 7. Expand this, we're going to get 5 lambda, 7 lambda. So by comparisons, k is equal to 5 lambda. Another one will be 5 is equal to 7 lambda. So here we're going to move 7 to the other side. Then lambda is equal to 5 over 7. So here to find the k, we're going to substitute the lambda here with 5 over 7. So k is equal to 5 times 5 over 7, which is equal to 25 over 7. Question number 7. The Beats Company are promoting a big sale in conjunction with 9 September Sales Carnival. All smartphones are sold given a sale discount of 15%. The price D after the sale discount is given by the functions dp equal to 0.85p, where p is the original price of the smartphone. Intan plans to buy a smartphone from Beats Company. Since she was selected as the company's 100,000th customer, she is eligible for a RM20 coupons for the smartphone purchase. The price K after the coupon discount is given by the functions KP equal to P minus 20, where P is the original price of the smartphone. A. Intan may use both price discounts. Write a composite function based on the following situations. Number 1, situation 1. Taking the sale discount first, then taking the coupons. So here we have two functions. One is function D, represents the sale discounts, and function K, which represents the coupon discounts. For situation 1, sale discount is the first function followed by the coupon discounts. To write the composite functions, the name will be the second function first, followed by the first one. Then the composite function for situation 1 will be KD with the input of P. This means we're going to insert the function D into the function K. So we're going to insert the function D into the function K at the P here. So the composite function KD will be 0.85P minus 20. As for situations number 2, it will be coupon first, followed by sale discounts. Then the composite function for situation number 2 will be dk with the input p. This means we're going to insert function k into the function d. So we're going to insert the function k into the function d at the p here. So it will be 0.85 bracket p minus 20. So if you expand this, then it will be 0.85p minus 17. Questions B. Hence, calculates the lowest price paid by Intan if the original price of the smartphone is RM1899. State your answer to the nearest RM. If we refer to the composite function in A, the composite function KD and DK, the difference will be one of them is minus 20 and the other one is minus 17. Therefore, the composite functions KD, which minus 20, will give the lowest price. So KD with the original price of 1899, this will equal to 0.85 times 1899 minus 20. The answer will be RM 1594.20. 15. As the question asking you to state the answer to the nearest RM, then the lowest price will be RM 1594.00. Questions at A. Given that A is the first term and D is the common difference of an arithmetic progression, show that the sum of the first n terms of the progression is Sn equal to n over 2 bracket 2a plus n minus 1d. Let's say there is an arithmetic progression with 5 terms starting from number 2 to 14. So the sum of these 5 terms will be 2 plus 5 plus 8 plus 11 plus 14. So now, if I duplicate this sum of 5 terms, but now I arrange this in reverse order, then it will be 14 plus 11 plus 8 plus 5 plus 2. So if we sum up these two as 5, then it will be 2 plus 14, which is equal to 16. 5 plus 11 is going to be 16. 8 plus 8 is going to be 16. 11 plus 5 is going to be 16, and 14 plus 2 will be 16 as well. So for this number 16, we can say this is the sum of the first term and the last terms. So now here I'm going to have 2 as 5. This is equal to, so here I have 5, 16. So it's going to be 5 times 16. So S5 here will be equal to 5 times 16 and divide by 2. So in general, this number 5 here is representing the number of terms, as well as this number 5. This number 16 is the sum of the first term and the last terms. In general, let's say the last terms is the nth terms. Then we can represent the last terms as Tn equal to a plus n minus 1d. So if we substitute the L here with a plus n minus 1d, then Sn is equal to n times a plus n minus 1d over 2. And if we rearrange this, then Sn is equal to n over 2, 2a plus n minus 1d. So this is from a specific example to understand how this formula is formed. So after you can understand the process of this, then we can show the sums of the first n term of an arithmetic progression. So in general, Sn, if that you sum up the first terms, the second terms, the third terms, until the second last terms is going to be Tn minus 1, and the last term will be Tn. So here the T1 we can represent it as A, and T2 as A plus D, T3 as A plus 2D. And the second last term, A plus n minus 2D. And the last term will be A plus n minus 1D. Next, we're going to duplicate this Sn and rearrange this in reverse order. So now if we sum these two Sn together, the terms that we're going to get is the first term plus with the last term, which is 2a plus n minus 1d. So 2Sn, this is equal to the nth terms multiply with the 2a plus n minus 1d. Then Sn will be n over 2, 2a plus n minus 1d. Questions B. Zaki Bakery has sold 400 cakes on the first week. On the second week, the sales has decreased by 8 cakes until the 7th week. On the following week, due to the promotions, the sale has increased by 100% compared to the previous week. By using the formula given in at A, Calculate the number of cakes that has been sold starting from the first week until the promotion week. So the number of cakes sold by Zaki Bakery will form an arithmetic progression, starting with 400, followed by 392, followed by 384, and so on until the 7 weeks. So here the A is 400 and the D will be -8. So the total number of cakes sold from the first week to the 7th week will be S7 equal to 7 over 2, 2 times 400 plus 7 minus 1 times -8, which is equal to 2632. So based on the questions on the following weeks, this is referred to the 8th weeks. The sale has increased by 100% compared to the previous weeks. So here the previous weeks is referred to the 7 weeks. So first we're going to find the number of cakes sold on the 7 weeks. So T7 is equal to 400 plus 7 minus 1 times -8, which is equal to 352. So the number of cakes sold on the 8 weeks, which is the T8, increased by 100% is mean double. Then it will be 352 times 2, which is equal to 704. So the number of cakes sold will be the S7 plus the T8, which is equal to 2632 plus 704, which is equal to 3336. Questions number 9. Given that the equations of the curve is y equal to 2x squared plus x plus 1, A. Find the equations of the normal to the curve at the points 2, 11. So this equation is a quadratic equation with the A equal to 2, which is greater than 0. So let's say this is the curve and the points 2, 11 is here. Then these green straight lines which touches the points 2, 11 will be the tangent. Then this blue straight line which is perpendicular to the tangent will be the normal. So first we're going to find the gradient of the tangent. So first we're going to differentiate the equations. So dy dx is equal to 4x plus 1. To find the gradient of the tangents, we're going to substitute the x coordinates, which is the 2, into the dy dx. It will be 4 times 2 plus 1, which is equal to 9. As normal is perpendicular to the tangent, so when the gradient of the normal, we multiply it with the gradient of the tangent, which is 9, the answer is equal to -1. Then the gradient of the normal will be -1 over 9. So next we're going to find the c for the normal. So for now, the equations of the normal will be y equal to -1 over 9x plus c. To find the c, we're going to substitute the coordinates 2 11s into the equations. So 11 equal to -1 over 9 times 2 plus c. Then c will equal to 11 plus 2 over 9, which is equal to 101 over 9. Then the equations for the normal will be y equal to -1 over 9x plus 101 over 9. Questions B. Hence, finds the coordinates of the points such that the normal meets the curve again. So based on the diagram here, if we extend the normal, then it will meet the curve here again. So the coordinates of the points here is the intersection point between the curve and the normal. So we're going to solve this using the simultaneous equations. So let's say the equation of the curve is the equation 1 and equations of the normal is the equations number 2. So when you substitute the equations 1 into the equations 2, then it will be 2x squared plus x plus 1 equal to negative 1 over 9x plus 101 over 9. So here I'm going to multiply each term with number 9 so that I can get rid of the denominator of number 9. So here you're going to get 18x squared plus 9x plus 9 equal to, so the number 9 here will cancel, just left with negative x plus 101. As this is a quadratic equation, so we're going to write it in general form. Then it will be 18x squared plus 10x minus 92 equal to 0. So here we can simplify the equations by dividing every term with number 2. So 9x squared plus 5x minus 46 equal to 0. Using factorization, you're going to get 9x plus 23 and x minus 2 equal to 0. So here x is equal to negative 23 over 9, or x is equal to 2. So here the x equal to 2 is referred to this coordinate. So the x coordinate for the other points will be the x equal to negative 23 over 9. To find its y coordinate, we're going to substitute the x equal to negative 23 over 9 into equations number 2. Then y is equal to negative 1 over 9 times negative 23 over 9 plus 101 over 9, which is equal to 932 over 81. Therefore, the coordinates of the points will be negative 23 over 9, 932 over 81. Questions number 10. Diagram 3 show the curve y equal to fx and the straight lines y equal to gx. The curve y equal to fx and the straight line y equal to gx intersect at points O, P, and Q. Given the area of the shaded region A is 1 and 5 over 12 units square, A finds the value of the following. So based on the diagrams, the points here will be number 1, and the region A is the area under this curve, which is the fx. To find the area A, we're going to integrate from 1 to 0 of the fx in respect to x, and the answer will be 1 and 5 over 12. So for questions A1, the upper limit and the lower limit, if you compare to this one, it is in reverse order. Therefore, the value will be negative 1 and 5 over 12, as both of them are integrating the fx. For questions number 2, we're going to find the value of k. So first, we're going to split this. So it will be integrating 1, 0 of 3 fx in respect to x minus integrating from 1, 0 of k in respect to x, and this is equal to 12. So for this part, we're going to move the 3 to the front. It will be 3 times integrating 1, 0 fx in respect to x. So minus, as k is a constant, so when we integrate it, we're going to get kx. And this is equal to 12. So for this part, this is referred to the region A, which is 1 and 5 over 12. So it will be 3 times 1 and 5 over 12 minus, we're going to substitute the upper limit, lower limit into the x. So we're going to get k times 1 minus k times 0. This is equal to 12. So here we're going to get 17 over 4 minus k equal to 12. Then k is equal to 17 over 4 minus 12, which is equal to negative 31 over 4. Questions B. Given the area of the shaded region A is representing by this, finds the equations of the fx. So here the terms inside the bracket here has been integrated. To find the equation, we're going to differentiate this. So fx will be equal to, so we're going to move the 4 to the front, so it will be 4 times x the power minus 1 x cubed over 4. Then for the second terms, move the 3 to the front, minus 3 times 4 over 3 x the power minus 1 will be square, plus move the 2 to the front, 2 times 5 over 2, and the power here minus 1, which will be x. So here the number 4 can be simplified, so just left with x cubed minus, simplify the 3, 4x squared, simplify the 2, it will be plus 5x. Then this will be the fx. Questions 11. A team of 6 students will be formed to participate in the state level STEM carnival. The establishment of the team will be chosen from 7 male students and 5 female students. Finds the number of different ways to form the team if number 1, female student exceed male students. For the number of female students to exceed the male students in a team of 6, then the female student should be more than 3. So case 1 will be, let's say we have 4 female students in the team, then we're going to have 2 male. Then case number 2, let's say we have 5 female students in the team, then it will be left with only 1 male. As we want the female student exceed the male student, therefore the male student cannot be 0. So we only have these 2 cases. So this is about combinations. To find the case 1, we're going to use 5C4 times 7C2 plus the second case, that will be 5C5 times 7C1. So this is equal to 105 plus 7, which is equal to 112. Number 2, at least 4 selected male students, which means the minimum numbers of the male student will be 4. So for case number 1, let's say we have 4 male students, then the female student will be 2. Or case number 2, let's say we have 5 male students, then we're going to have 1 female student. Or for case number 3, let's say the whole team consists of male students, then we're going to have 6 male and 0 female. So for case number 1, it will be 7C4 times 5C2, then plus with the case number 2, which is 7C5 times 5C1, plus the case number 3, which is 7C6 times 5C0. So this is equal to 350 plus 105 plus 7, which is equal to 462. Questions B. Diagram 4 shows the routes for an object. The object can only move up or to the right. Find the number of routes for the object to move from point A to point B. So the movement from point A to point B, we can divide it into 2 different parts. The first part is from the point A until these points here. As the object can only move up or to the right, so no matter which route you are choosing, from point A until this point, the object always going to travel 6 places. For example, if A travel like this, 6 places, or even like this, it's also going to travel in total of 6 places. Therefore, the total number of routes from points A until these points here, it will be 6 factorial. But for the movements going up, for example, no matter which route you are choosing, you're always going to move up 2 places. For example, like this or like this. These two movements will be considered as identical as you are moving up 2 places. Therefore, we're going to divide this 6 factorial with 2 factorials for the route for the object moving up. The same concept applies when the object moves to the right. So, for the first part, the object will always move 4 places towards the right, no matter which route you are choosing. For example, like this or like this. This will be considered as identical as well. Therefore, for the movement towards the right, we're going to divide this by 4 factorial. Then this will be the roots for the first part. And for the second part, which from this point to the B, the same concept apply. So in total, for the second part, you're always going to move up 3 places and 4 places to the right. So in total, 7 places. So the number of roots for the second part will be 7 factorials. But for the parts that's moving up, so these 3 places going up will be considered as identical. So we need to divide this by 3 factorials. And the movement to the right will be identical. So we're going to divide it by 4 factorials. So the number of roots will move from the first part and with the second part. So here we're going to multiply it. So this is equal to 15 times 35, which is equal to 525. Questions 12a. A participant has shot 3 times in a training session. 1. Let H be the result of hitting the target and H prime be the result of not hitting the target. Draw a tree diagram to show all possible outcomes. So for the first shootings, the result can be either the participants hit the target or not hitting the target. And for the second shootings, it can shoot the target or not the target again. So we're going to get H and H prime here. As for the third shooting, the similar result is going to get. So this will be the 3 diagrams. And the possible outcomes, for the first one here, we're going to get all hit. And the others possible outcomes will be like this. Questions number 2. If X represents the number of times hitting the target, which is the H, show that X is a discrete random variables. So here the number of times hitting the target will be 3, followed by 2, 2, 1, 2, 1, 1, and 0. Therefore, the X will be 0, 1, 2, and 3. X is a discrete random variables because its values can be counted. Questions B. The random variable X of 12 trials is a binomial distribution with a standard deviation of square root 5 over 3. If probability of success is P, find the possible values of P. So here we can solve this using the formula. So standard deviations is equal to the square roots of n, p, q. So here the standard deviation, we're going to substitute it with the square root of 3 over 5. So this is equal to square roots. So the n here will be the 12 trials. So it will be 12 times p. And as for the q, we know that the total probability p plus q is equal to 1. Therefore, q is equal to 1 minus p. So here I'm going to substitute the q with 1 minus p, so that we can only have one variables in these equations later on. So to get rid of the square root, so we're going to square both sides. So what left is 5 over 3 equal to, so expand this, you're going to get 12p minus 12p squared. As this is a quadratic equation, so we're going to write this in general form. So 12p squared minus 12p plus 5 over 3 is equal to 0. So here I'm going to multiply each terms with number 3 to get rid of the fractions. So here we're going to get 36p squared minus 36p plus, so here will be just 5. So using factorizations, we're going to get 6p minus 5 and 6p minus 1. This is equal to 0. Therefore, p is equal to 5 over 6, or p is equal to 1 over 6. Questions 13a. Solve the simultaneous equations. So for the first equations here, this number 9 and 81, we can change it to base 3. Then 3 to the power of 4x times 1 over 3 squared to the power of y minus 1 is equal to 3 to the power of 4. As for the 1 over 3 squared, we can write this as 3 to the power of negative 2. So next we're going to expand this. It will be 3 to the power of negative 2y plus 2. As the operation here is multiplication, then using the law of indices, we can write this as 3 to the power of 4x plus negative 2y plus 2. So here we're going to get 3 to the power of 4x minus 2y plus 2 equal to 3 to the power of 4. Now on the left hand side and right hand side, we are having the same base, then we can compare the power. Therefore, 4x minus 2y plus 2 is equal to 4. So here we can move the 2 to the other side. So 4x minus 2y is equal to 4 minus 2, which is 2. And we are able to simplify this equation by dividing every term with number 2. Therefore, 2x minus y is equal to 1. As for the second equation, this number 8 and 64, we can change it to base 2. So number 8 is 2 to the power of 3 over 2 power of y. This one is equal to 2 to the power of 6. So for the left hand side, as the operation is divisions, we can write this as 2 to the power of 3x minus y. This is equal to 2 to the power of 6. So right now, the left hand side and the right hand side are having the same base. Then we can compare the power. Therefore, 3x minus y is equal to 6. So now we're going to solve for these two equations. So let's say we let this equation as equation 1 and this is equations number 2. Using elimination method, so here I'm going to use equations number 2 minus equations number 1 to eliminate the y. So 3x minus 2x, we're going to have x. And negative y minus negative y, this will be equal to 0. This is equal to 6 minus 1, which is 5. Then we're going to substitute x equal to 5 into the equations number 1 to find the value of y. Then 2 times 5 minus y is equal to 1. So 10 minus y is equal to 1. To find the value of y, so y is equal to 10 minus 1, which is 9. Then we already solved these simultaneous equations. Questions B. Diagram 5 shows isosceles triangle ABC. Given that BA equal to BC and M is the midpoint of AC, find tangent angle BAC in the form A plus B sub 5 over C, with A, B, and C are positive integer. So here will be the angle BAC. Tangent is opposite sides over the adjacent sides. So here the BM will be the opposite sides, where the AM is going to be the adjacent sides. As M is the midpoint, then the length of AM will be 4 plus 6 sub 5 divided by 2, which is equal to 2 plus 3 sub 5. So tangent angle BAC will be equal to 3 plus 2 sub 5 over 2 plus 3 sub 5. So to rationalize the denominator, so we're going to multiply this with its conjugate. So the conjugate sub here will be 2 minus 3 sub 5 over 2 minus 3 sub 5. So as we expand the numerator part, this will equal to 6 minus 9 sub 5 plus 4 sub 5 minus 30 over 4 minus 45. So next we're going to get negative 24 minus 5 sub 5 over negative 41. So here the question stated that the value of ABC are positive integer. So next we're going to factorize. So negative bracket 24 plus 5 sub 5 over negative 41. So here the negative can be cancelled. Therefore the answer will be 24 plus 5 sub 5 over 41. Questions 14. Diagram 6 shows a garden in the form of sector AOB of a circle with center O. The radius and angle of the sector are r meter and 2 theta respectively. In the garden, a circular plot is to be planted with roses, given that the radius of the plot is r meter. So A show that the capital R is equal to r bracket 1 plus 1 over sine theta. So here the clue will be the sine theta. So in the diagram, the angle here is 2 theta. So I'm going to divide it by half. So based on the diagram, the OB and OA is the tangents to the circle. So when we draw a straight line from the connecting points of the tangents to the center of the circle, then the angle here will be 90 degrees. So here the radius of the circular plot will be the small letter r. Therefore, this will be the small letter r. So the blue straight line here is also the radius of the sector AOB, which is equal to the capital R. Therefore, the length of this part will be capital R minus the small r. And here this will be the theta. So using this right angle triangle, the sine theta will be the opposite sides over the hypotenuse. Therefore, we can write sine theta is equal to small letter r over capital letter R minus the small r. So next, we're going to have capital R minus small r times sine theta. This is equal to small letter r. Then capital R minus r is equal to small letter r divided by sine theta. Then we're going to move the small letter r on the left hand side to the right. Then capital R is equal to r plus r over sine theta. So as both terms are having the r, then we can factorize this. Then capital R is equal to r bracket 1 plus 1 over sine theta. Questions B. Given that theta is equal to 30 degrees, finds the ratio of the garden that is to be planted with roses. So here we're going to substitute the theta with 30 degrees into the formula in A. Therefore, the radius of the sector AOB is equal to r bracket 1 plus 1 over sine 30 degrees. Then the capital R is equal to 3r. So the garden is a circle. Then the area of the garden will be pi r square. As for the area of the sector AOB, we're going to use the formula 1 over 2 r square theta. So here the angle AOB will be 2 times 30 degrees, which is equal to 60 degrees. Then we convert this 60 degrees into radian. This will be equal to 60 degrees times pi over 180 degrees, which is equal to pi over 3 radian. So the area sector AOB will be 1 over 2. The radius here we're going to use the 3r. Then it will be bracket 3r square times the angle, which is pi over 3. So here we're going to get 1 over 2 9r square times pi over 3. So here we can simplify the 3 and the 9 here. Then the area will be 3 pi r square over 2. So here the ratio of the gardens to the area of the sector AOB will be pi r square over 3 pi r square over 2. So this is also equal to pi r square times 2 over 3 pi r square. So here we can cancel, simplifies the pi r square. So the ratio of the gardens to the area of the sector AOB will be 2 over 3. Question C. Hence, calculate the length of fencing required to fence along the shaded region when r is equal to 15. In questions B, we already find that the capital R is equal to 3 times small letter r. So when the capital R is equal to 15, then the radius of the circle will be r equal to 15 over 3, which is equal to 5. So to find the arc length here, the total angle here will be 120 degrees. So we're going to convert this 120 degrees into radian. It will be equal to 120 degrees times pi over 180 degrees, which is equal to 2 over 3 pi radian. So we can find the arc length using the formula r theta. So the r will be 5 and the theta will be 2 over 3 pi, which is equal to 10 over 3 pi. Next, to find the length here, this length here is opposite this 60 degrees. And this 5, which is the radius, is adjacent to this 60 degree. So here we can use the tangent 60 degree. This is equal to the opposite length over 5. So the opposite length will equal to 5 times tangent 60 degree, which is equal to 5 sub 3. So the length of fencing will be, we're going to sum up the arc length and the two sides here. It will be 2 times 5 sub 3. So the answer will be 27.79. Questions 15. A. Given cos 20 degree equal to h and sin 48 degree equal to g. Express sin 68 degree in terms of h and or g. So here if we look at the angle given, when we sum up the 20 degree and the 48, it is actually equal to the 68. So here we can express the sin 68 using the additions formula. And we can replace the A and B here with the angle 20 and 48. So this is equal to sin 20 times cos 48 plus cos 20 times sin 48. So for the parts cos 20 degree, we already know that this is equal to h. And for the sin 48, this is equal to g. So now we need to find what is the sin 20 degree and the cos 48 degree. So for cos 20 and the sin 48, both of them are lines on the first quadrant. So first, for the cos 20 degree, which is equal to h, we know that the cos is the adjacent over the hypotenuse. Then we can also write the cos 20 degree equal to h over 1. Therefore, the h is the adjacent and the number 1 is the hypotenuse. So here will be the angle 20 degree. This will be the opposite, adjacent and hypotenuse. So here will be the h and here will be the 1. So for the opposite side, we can find it through the Pythagoras theorem, as this is a right angle triangle. So the opposite side will be the square root of 1 square minus h square, which is 1 minus h square. As for the sin 48 degree, which is equal to g, we can also write this as sin 48 degree equal to g over 1. So sin is the opposite sides over the hypotenuse. So here will be the 48 degree. Again, this is the O, A, and H. So here the opposite will be the G, hypotenuse is the 1. And for the adjacent, then we can find it through the Pythagoras theorem. It will be 1 square minus G square. So it will be square root 1 minus G square. So now for the part sin 20 degree, we're going to refer to the diagram with the 20 degree here. So sin 20 degree will equal to O over H. Then it will be square root 1 minus H square over 1, which is the same as square root 1 minus H square. And for cos 48 degree, we're going to refer to the 48 degree here. So cos 48 degree is equal to A over H. So in this case, it will be square root 1 minus G square over 1, which is equal to square root 1 minus G square. So now we already have all the informations. So we're going to replace the sin 20 here with square root 1 minus H square times the cos 48, which is the square root 1 minus G square, plus cos 20 degree, which is the H, and sin 48 degree, which is the G. Then this will be the sines for 68 degree in terms of H, N, or G. Questions B. Solve the equations for cotangent square theta minus cosec square theta equal to 2 for the theta is in between 0 to 360 degree. So based on the list of the basic identities, cosec square A equal to 1 plus cotangent square A. So we can replace this cosec square theta here with 1 plus cotangent square theta. Then the equation will be 4 cotangent square theta minus bracket 1 plus cotangent square theta. This is equal to 2. So 4 cotangent square theta minus 1 minus cotangent square theta, this is equal to 2. So when 4 cotangent square theta minus cotangent theta, we're going to left with 3 cotangent square theta. And we're going to move the negative 1 to the other side. So 2 plus 1 is equal to 3. Then move the 3. So cotangent square theta, this is equal to 3 divided by 3, which is 1. So cotangent square theta, we can write it as 1 over tangent square theta. This is equal to 1. So when we move it to the other side, it will be 1 equal to tangent square theta. So next, when you move this square to the other side, then tangent theta will equal to plus minus square root 1. So the answer for the square root 1 is still going to be 1. Therefore, tangent theta is equal to plus minus 1. So when the value of tangent is positive, the angle is at the quadrant 1 and quadrant 3. When the tangent, the value is negative, it lies on the quadrant number 2 and quadrant number 4. So in this case, the theta lies on all the 4 quadrants. So here the reference angle, when the tangent theta is equal to 1, the angle is 45 degree. Then the angle here, all of them will be 45. So the angle for the theta in the first quadrant, this will be 45 degree. And for the angle in the second quadrant, it will be 180 degree minus 45 degree, which is 135 degree. And for the angle in the third quadrant, it will be 180 degree plus 45 degree, which is equal to 225 degree. And for the angle in the fourth quadrant, it will be 360 degree minus 45 degree, which is 315 degree. Question C. Given theta equal to 30 degree, show that cos theta over 2 is equal to square root 2 plus square root 3 over 2. So for this questions is involve the half angle involving cos. So refer to the double angle formula. We're going to solve this using cos 2a equal to 2 cos square a minus 1. So here we're going to replace the a with theta according to the questions. So when the angle is half, then the formula will be cos theta equal to 2 cos square theta over 2 minus 1. So now we're going to substitute the theta equal to 30 into the theta here. So it will be cos 30 degree equal to 2 times cos square 30 degree over 2 minus 1. So the value of the cos 30 degree is square root 3 over 2. So this is equal to cos square 15 degree minus 1. So next, move the 1 to the other side. So 2 cos square 15 degree, this is equal to 3 over 2 plus 1. Next, I'm going to combine this as a single fractions. So 2 cos square 15 degree, this is equal to sec3 plus 2 over 2. Then move these 2 to the other side. It will be cos square 15 degree equal to sec3 plus 2 over 2 times 1 over 2. So the answer here is equal to sec3 plus 2 over 4. Next, move the square to the other side, so it will be cos 15 degree equal to square root. And if I arrange this will be 2 plus sec3 over 4. So this is the same as square root 2 plus sec3 over square root 4. So the answer for the square root 4 is equal to 2. Therefore, cos 15 degree, this is equal to square root 2 plus sec3 over 2.